All right, good afternoon. I'm going to see if I can get this to work. What we're going to do is find the boundary points. I'm already messing up. So what we're going to do is set each factor equal to 0, and that is going to give us what we call the boundary points, and that will let us solve this inequality. So here is how we start. Solving each one, I get these three values. So now what we need to do is graph the boundary points on a number line. So sketch a number line here. So here's 3, 4, and 7. So because this is an inequality, what we're looking for is a solution set. So in other words, our answer is going to be expressed in interval notation. So what we're going to see happens is our answer is either in region A, region B, region C, or region D, or some combination of those. So what we're going to do is test each region and see which one contains values that make that inequality true. So let's jot down the inequality right under our number line so we can look at it easily. And now notice that we're looking for values that are less than or equal to 0. So the less than 0 is the part we want to concentrate on. So let's think of a value in region A, which is going to be any number less than 3. So 2, of course, would be a good place to start. So let's do that, and I'll just highlight that I'm filling in 2 for each of those. So this would be 2 minus 3, 2 minus 4, 2 minus 7. So that would give us -1, -2, -5. So if I multiply these two together, I get a +2, but I still have a -5. And 2 times -5 is -10. So is -10 less than or equal to 0? Yes, because it is less than 0. So what we do is I just kind of put a check mark in that region, and what that tells us is that all the points in that region are solutions to our original inequality. So now we'll do the same thing for region B. Now this one's a little tricky because there's not an integer between 3 and 4, so we have to say 3.5. So just replace every x with 3.5. Now I'm going to show you a little trick here. We don't actually have to compute the numbers. All we need to do is find out if the value is positive or negative. And we'll do a couple so you'll understand what I'm saying. So 3.5 minus 3, well, that's going to be a positive value. 3.5 minus 4, well, that's going to be a negative value. And 3.5 minus 7 is also going to be a negative. So let's go ahead and multiply a positive and a negative. What does that give us? A negative. And then we're going to multiply that by the negative that's left, and that gives us a positive. So here's our question. Is a positive number less than or equal to 0? And that answer is going to be no. So we cross out that region. That's not part of our solution. So now let's try something in region C. So a number there could be 5. So we're going to have 5 minus 3, 5 minus 4, and 5 minus 7. We're trying to see if that's less than or equal to 0. So again, don't worry about the number. We really just need the sign. So that's a positive, and that's a negative. So multiplying, I get a positive times a negative. That gives me a negative. And a negative number is less than or equal to 0 because it's less than. So that's going to be a yes for that region. Let me come back and say a yes here. So that means that all the points between 4 and 7 do satisfy that inequality. All right, last one. Think of any number greater than 7. I'm just going to use 8. So 8 minus 3, 8 minus 4, 8 minus 7. So 8 minus 3 is going to be a positive. 8 minus 4 is a positive. 8 minus 7 is a negative. Whoops, okay. I almost made a mistake there. You're probably there saying, wait a minute, no it's not. 8 minus 7 is a positive. So here I have a positive times a positive times a positive. Is that less than or equal to 0? No. So that region is no. So that's how I knew I had made a little mistake there, is because the regions will always alternate. Okay, so what we see now, so far, is that our answer is all the answers or all the numbers between 4 and 7 and everything that's less than 3. But here's the question. What about the boundary numbers themselves? Are the boundary numbers included in the solution set? Well, the answer is that the boundary points are included when it's less than or equal or greater than or equal. So in other words, it is the equal sign that tells you to include the point. So if you remember, when we're doing interval notation, that means we're going to use a bracket at the end of our set. I guess I need to use a different notation there. So for this answer, we're going to have from negative infinity to 3 with a bracket, picking up at 4 to 7 with brackets. We put a little union symbol, and I think in Excel they just put a comma. So let's come over here and state what happens when it's not included. So when the boundary points are not included, when it's just less than or greater than. So there's no equal sign. So in that case, you'll use parentheses at the end. But here is our solution. We'll put the word or here. And hopefully that helps.